Welcome to Pomodoro Joe for Wednesday, May 31st, 2023. Today we're looking at LeetCode problem 1396, Design Underground System. This is a medium problem. An underground railway system is keeping track of customer travel times between different stations. They are using this data to calculate the average time it takes to travel from one station to another. Implement the underground system class. Has three methods: void, check-in, takes an ID, a station name, and a t, which is an integer, so that's a time. A customer with a card ID equal to ID checks in at the station name at time t. A customer can only be checked in at one place at a time. Awesome. Next one, check out. We have an ID, a station name, and a time, also an integer. A customer with card ID equal to ID checks out at the station with station name at time t. And finally, we have double get average time. It takes two station names, two strings. Return the average time it takes to travel from start station to end station. The average time is computed from all the previous travel times from start station to end station that happened directly, meaning a check-in at start station followed by a check-out at end station. Oh good, so we don't have to worry about multiple stops. Cool. The time it takes to travel from start station to end station may be different from the time it takes to travel from end station to start station. Okay, that's good to know. We'll have to keep track of specific start and end station. There will be at least one customer that has traveled from start station to end station before get average time is called. You may assume all calls to the check-in and check-out methods are consistent. If a customer checks in at time t sub 1, then checks out at time t sub 2, then t sub 1 is less than t sub 2. All events happen in chronological order. All right, so we have a check-in with a customer ID, station name, and the time they check in as an integer. Then we have a check-out with the customer ID, the station name as a string, and the time as an integer. And then we have a get average time, which takes two station names. And then we have some constraints, I'm sure. Yep, we have some constraints here. All right. So with that, we'll put 25 minutes on the Pomodoro timer and get started. So this one should be pretty fun. So in the init, we will initialize some storage for the different pieces of data that we need to hold on to. In the check-in, we will actually store the user ID, station name, and the time they checked in. We just need to hold on to those so that we can use them later when we calculate the time travel. At checkout, we don't actually need to store the checkout time, but we do need to use the station name and the time to find the delta time between the check-in and the checkout. And then we will need to store that combination of the station name, the start station and the end station, and it's mapping to something. Well, it looks like based on our get average time, in the get average time, we'll need to look up that something. So that's going to be the total travel time. So the time, the sum of the times from all the different trips. And we'll need to keep track of how many trips were made. So we can take the total time divided by the number of trips to get our average time. So for every start station and end station, it looks like we'll need to keep track of two pieces of data, the total travel time and the number of trips. Okay, so let's see. Let's start out here with our storage. First thing in our check-in, we will need to keep track of the user ID and the station they checked in at and the time they checked in. So we can just do a lookup on the user ID. Since we know they can't be checked into multiple stations at the same time, we can just key on the user ID, store the station name and the time they checked in as the value. So this will be a dictionary. All right, so the key will be the user ID, and the value, well, we'll store that as a tuple. So that will be the station name and the time. Now, if you're doing this in a language that doesn't allow for tuples, you could store this as a list or some struct. All right, or you could actually keep two separate dictionaries if you wanted to, although I wouldn't recommend that. Okay, so we need to do self, and we'll call this traveler or travelers, and it's going to be a dictionary. That dictionary will be a dictionary of tuples. All right, the next piece that we'll need, we need to keep track of our start station, end station, and how they map to the total travel time between the two stations and the number of trips that were taken. So we'll have another dictionary here. This one's going to be a little bit more complicated. So the key to this other dictionary will actually be a tuple. That's going to be our start station and our end station together. So So this is a compound key. The key is both the start station and the end station wrapped in a tuple. Now, if you're using a language that doesn't have something like a tuple that you can key on, you can actually make this a string and use the start station string and append the end station string, probably with some delimiter string in between. So like start station, end station. That way it's more likely to be unique. All right, and then the value here. Well, this will also be a tuple, and this one will keep track of the total travel time, so total time, and the number of trips, so trip count. All right, so let's see itself, and we'll have, what will we call this one? I'll just call this trip data, or travel data. And this again will be a dictionary. So we can make this a default dictionary since we already know we'll be using tuples, but I think I'm just going to make it a regular dictionary for now, and we can come back and make it a default dictionary later if we want. All right, so we have our two pieces of storage. We have our travelers, which will store our station name and the time, and then we have our travel data, which will keep track of from station to station, total time, and the trip count. Okay, cool. So then when we check in, we just update our travelers. Since we know that this traveler can only be at one station at a time, it's pretty simple to update this one. We just update the ID, and we'll keep track of a tuple with the station name and the time they checked in. Now with checkout, we'll just grab the station name and the time from the travelers, and we'll find the time delta, and then we'll have the start station, end station combination, and we'll store that in our travel data. So let's see, we'll have start station and the start time, and that will just be whatever we stored in our self.travelers for this user. So we've got our start station and our start time, and we pull that out of our travelers dictionary for this traveler's ID. Next, we need to calculate our time delta. So that'll be the end time, so this current t, minus our start time. All right, and what else do we need here? Well, we just need a new key for our travel data dictionary. So this key, I'm going to use a tuple, so this will be start station and end station. Now our end station is just this station name here. And again, if you are using a language that doesn't support tuples like this, you can make a string out of the start station and end station to make your key. All right, then our travel data gets updated. So let's see, I'm pulling a tuple out of the travel data first, then I need to update it, and then I need to put it back into the travel data. So maybe instead of making this a tuple, I'll make this a list. That makes it a little bit easier. And we can always come back and make this a tuple later. Tuples are generally faster, but they're immutable. So lists being mutable make it a little bit easier for us here. So let's see, I'll grab this travel data. Okay, so we'll grab the data out of this travel data for this key, but that's only if the key is in this travel data. We might not have any data yet for this set of stations, and if we don't, then we need to have some default value. Otherwise, we have 0 total time and 0 trips so far. Okay, so this will be our data. Now we just update our data. So data at index 0, this is our travel time. We're going to add our time delta here. Something like that. And then data for the number of trips, we'll just add one more trip. Now we do need to put this data back into our dictionary. If we didn't use our default value here, we could actually just make these modifications because it will modify the one that's in the dictionary directly. However, since we have this default data, we actually need to put this back into our data here. So this one is definitely more complicated than our check-in. And now our get average time. This one should be pretty straightforward. We just take our start station, end station, create our key. Let's see, I'll just grab that here actually. And then this one will be end station. So we create our key, then we'll grab our travel data. We'll grab that here. So our travel data is going to be the time, or total time, I'll call it, and the number of trips. So I'll call that trip count. That's going to be the travel data for this key. And then we just return the total time divided by the trip count. Note here that I'm using a floating point divide or not an integer divide, because we do want floating point or decimal values here. All right, and I think this should do it. So we've got our travelers, which is a dictionary mapping our traveler ID to the start station and the time they started. Then we have our travel data, which will map the start station and end station combination to the total time of all the trips taken between those two, and then the trip count, so the number of trips taken between the two. So that way we can calculate our average. When we check in, all we have to do is store the station name and the time for our user or our traveler ID. Then when we check out, we just grab that start station and start time from the traveler's dictionary. We calculate our time delta. Then we'll put that time delta along with an updated trip count into our combination station, start station, end station travel data here. All right, finally in the get average, we use the combination key, the start station, end station, to grab the total time and trip count out of our travel data. Then we just return the total time divided by our trip count. All right, let's see if this works. Seems to work. Let's see how we do. And we pass. Let's see, we do okay. 53% for runtime, 14% for memory. Not too bad. Now let's jump back really quick and see what happens if we change this list to a tuple. So right now we're storing total time and trip count as a list. Now, actually, before we do that, maybe we'll do a default dictionary here. Do I want to do that? No, let's just change it to a tuple. Let's just keep this simple. All right, so instead of using a list, we'll use a tuple. Now, the main difference between the two is that a list is a referenced list, whereas a tuple is a value type. So you'll be passing the actual tuple around, and the tuple itself is not mutable. That means that we can't do this with a tuple. So we'll have to make a couple little changes here. All right, so we'll still grab the data out from this key travel data, but instead of having a list, if we need the default value, we'll grab a tuple. And then we have to do, instead of data at index 0 is time delta, plus equals time delta. We'll have to have some new tuple here. So let's call this new data. And that will just equal a tuple of data in index 0 combined with the data index 1 plus 1. So this creates our new tuple. And then we do have to put our new data into our dictionary. Let's see if this works. Oh, sorry here. Let's do this. Okay, so that works. Let's see if this gives us any type of improvement over the list implementation. And it does, pretty decent. Now we're beating 73% for runtime and 19% for memory. So that's up from 53% and 14%. So yeah, that's not too bad just by changing something from a list to a tuple. Now there's other things we could be doing here. Like we could be using a default dictionary, which might save us a little bit in here. But I think this is a pretty decent solution overall. All right, so that is it for me. Hope you enjoyed this. Hope you had fun. Hope you learned something. Hope you can go out and write better code.